This is a problem similar to a problem from your homework in section 11-4. Weights in kilograms of poplar trees were obtained from trees planted in a rich and moist environment. The trees were given different treatments identified in the table below. The data are from a study conducted by researchers in Pennsylvania State University and were provided by Minitab. Use a 0.05 significance level to test the claim that 4 treatments categories yield poplar trees with the same mean weight. Is there a treatment that appears to be most effective? So in this particular scenario, we are testing the claim that 4 treatments yield the same mean weight. So we are looking at mean and comparing means of more than 2 samples. So we will be using analysis of variance for this problem, and we are interested in setting up our null and alternative hypotheses. So the null hypothesis will be that the mean of the first one with no treatment is equal to the mean of the second one with no treatment is equal to the third and the fourth. And our alternative hypothesis simply says that at least one of them is different. So in this problem we are looking for a 0.05 significance level, and what we're interested in is really just digging out the p-value and then making our interpretation. So our p-value we will get from the calculator when we go through the analysis of variance test. Before you get to your calculator, or before we get to the analysis of variance test, we want to input our data into our calculator. So if we press that, I would put the no treatment column into L1, I will put the fertilizer column into L2, the irrigation into L3, and the fertilization and irrigation in the fourth list. So let me just add this last number, 1.64, and then now we're ready to go. So we're going to go back to our home screen, press second function in mode or second function in quit, and then now I'm going to find my analysis of variance. Let's go to stat, and I'll go to test, and then I'm going to go up to see ANOVA, analysis of variance, so I'll select that. And then I will go ahead and input the lists. So L1 is my first list, and I'll separate each list by a comma. Once I have all my lists, I'll close the parentheses and I'll just hit enter. So here is my output. If I scroll down, I'm going to see some of the numbers that I have for my factor and my error. The factor, also known as treatment, and so we have the sum squares, the mean squares of the factor, and then the sum squares, the mean squares for the error, and then I also have the pooled standard deviation computed for me. So we can take a look at all those numbers, and those numbers are things that you might want to write down. But more importantly, for our specific test, we're looking at the first 2 outputs. The F statistic, that's our test statistic, and our P, which is actually our p-value. So if we simply look at our output and focus on our p-value given here, and our test statistic given here, since we don't have critical values for our test statistic, we really can't do anything with this 6.14, but we do note that this is a fairly large number, and more importantly we can get our conclusion from our p-value. So we can say our p-value is less than our alpha significance level. We can reject the null hypothesis, and the claim says that 4 yields the poplar trees with the same mean weight. So we can say that we have evidence to reject the claim that, and then the claim says that the poplar trees weigh about the same. So it looks like their weights are significantly different, or the mean weights look like they might be significantly different. We can kind of guess by looking at the data that the fertilization and irrigation, the trees that were fertilized and irrigated, look like they have higher weights compared to the ones with no treatment or fertilizer alone or irrigation alone. So we can say by inspection, it seems like the irrigation and the fertilization does help. Okay, I hope that's helpful.